We are now going to convert radical expressions into complex numbers. And we're going to start with the definition. If I have the square root of minus n, this is equal to I square roots of n. And notice I like to put my I in front of the radical if any is left. So as a simple example, suppose we have the square root of negative 25. Well, this is equal to the negative underneath the square root turns into an I, and that leaves behind the square root of 25. Well, the square root of 25 is 5, so this gives me as my final answer 5i. As a further example, suppose I want minus the square root of minus 16. Again, the negative underneath becomes an I with a negative in front of it and the square root of 16. Well, the square root of 16 is 4, so this becomes negative 4i. And notice, just like the square root symbol, when we're using the square root symbol with imaginary numbers, it still always returns the positive number. So if I want it to be negative, I need to put the negative on the outside. Well, let's look at 3 plus the square root of negative 49. Here, the 3 is already simplified, but our negative underneath the square root of 49, underneath the square root, becomes a 3 plus I root 49, which becomes 3 plus square root of 49 is 7i. And so my answer is 3 plus 7i. And finally, the square root of 5 minus the square root of negative 12 becomes, square root of 5 doesn't simplify and it doesn't have a negative. The minus is always going to be there. The negative comes out as an I, and the square root of 12. Well, 12 breaks down as 4 and 3. So this stays as square root of 5. The 4 breaks down again further as a 2i root 3. It's also acceptable to write this answer as minus 5 minus 2 root 3i, but I see a lot of students accidentally put the I underneath the radical, so I prefer it out front. But that's how we convert radical expressions into imaginary and complex numbers.